Our final speaker is Dimitris. He's my colleague here at Flower, and he's been working with a lot of folks out there. One of the folks he's been working with intensely is Google Cloud. We've had a lot of requests for being able to use Flower and Google Cloud together. And so, yeah, he's been chatting to a number of the engineers there to see how do we make this experience better. He volunteered for today's session to show us a bit about how Flower and Google Cloud look together. I think there's a bit of a demo or a broader discussion about this. And so I'm really eager to see what he can show you all, and hopefully that enables a lot of great experiments and systems and POCs to be possible. So over to Dimitris. Great to have you here.
Thank you for hosting me. Let me share my screen. Oh, I need to, yeah. All right. Second. Are you seeing the screen?
Yeah, we can see the screen fine.
Perfect. All right. Hello, everyone. My name is Dimitri. I'm a research engineer at Flower Labs. Today, I'm going to run you through how to use Flower on the Google Cloud Platform. So basically, how you can run any Flower application using Google Cloud Platform and along with the Google Cloud, Google Kubernetes engine. To start with, so just give it a background on how we have revamped Flower Platform lately. So right now, it's relatively easy to deploy or draft or create any Flower application you like. So you can have a huge LLM, or you can have a very tiny deep learning model, and this can be directly connected to a superlink, which is communicating with a couple of supernodes. So in other terms, the superlink is like a server acting as a server who is orchestrating the entire execution of the federated learning application throughout a number of devices. This device can be a mobile, a desktop, or a server, where a supernode is being hosted. So the idea here is that you can create, through the Flower platform, you create any application and just really easily submit it to a superlink that is already waiting for some Flower jobs to be run, and then distribute them down to the supernode, which are being hosted or deployed on dedicated devices. So the different runtimes right now that are being supported by Flower, the first one is, of course, the simulation runtime, so which is ideal for research purposes. So you can develop a Flower application to experiment with, create an ad hoc or a new idea and explore right away with the simulation engine. The nice and the beautiful thing with Flower is that once you have the simulation engine up and running and the Flower application up and running with the simulation, you can easily use exactly the same instructions and exactly the same structure of the Flower app and deploy it on a different on an actual devices, distributed devices, and this can be done through the Flower deployment runtime. Finally, the same application also can be run with a third-party runtime. So other platforms that support Flower, the Flower instruction, the Flower applications, and they can run Flower applications from scratch as well. So the core idea here, what I want to show is that you can start from simulation, go to the deployment, and then use another third-party platform to run exactly the same application that you defined from the very beginning while you're experimenting with Flower. So right now, I want to dive a little bit more on the Flower deployment side and what are the and how it's working and what are the different components and how everything interacts with each other. I'll start by giving an overview of the deployment runtime. Right now, through the Flower platform, we have achieved to enable different runs to run simultaneously on the same infrastructure. The Flower CLI has been optimized and has been revamped in order to support very easy commands on how to run, create, run, and generate create artifacts from the existing runtime. There is also user authentication, node authentication that can be supported out of the box. And of course, Docker deployment along with Kubernetes deployment. And last but not least, with the recently introduced Message API, which is actually a highly optimized way to communicate throughout the network of devices, the Flower devices. And we can support any type of communication protocol and of course, highly optimized security protocols as well. Just to give a little bit also background on the CLI and why is this so important is because, for instance, by running the Flower new, you are able to create a new Flower application. You create a template that can be run from simulation to deployment, as we saw in a couple of slides back. Why is this important? It's important because from research code, you can run right away into production code. This can be done through the Flower run. So once you create a template, you define your own instructions, your own client app, server app, and other scripts that you want to run over the network, over your Flower Federation network. And through a simple command, which is a Flower run, you can easily run and deploy and execute the Flower job. Last but not least, we also have other commands that are really can really give you more insights on how the federation performs. This can be done through the Flower log, where you can see real time the logs of active Flower runs. There is the list, which basically Flower list that gives you the statuses of the different Flower jobs. And finally, of course, the Flower stop, which basically can terminate or interact with a current actively running Flower run. Overall, we have simplified the Flower CLI in order to make it easier from going from research perspective to deployment in basically in very few commands, very easy, straightforward, few commands. Here, what I want to also dive a little bit deeper is a little bit what's happening under the Flower deployment runtime, under the hood of the Flower deployment runtime. To be precise, as we saw at the very beginning, we saw there are two core components, right? Flower components. One is a superlink, the other one is supernode. So superlink acts as a server in simple terms, and supernode acts as a client in other terms. Under the hood of the superlink has three APIs. The first one is the server app IO API, which basically communicates with the server app. The server app here is the script, let's say, or to make it easier, that contains what is the logic, what are the instructions that will be executed on the server side. The Fleet API coordinates execution across the connected supernodes, the supernodes that are connected to the superlink. And lastly, the exec API is the one that receives execution tasks by the user. So basically, a user, when he wants to perform, he or she wants to perform and run a Flower job, then by using Flower run, then this Flower run is being propagated to the exec API. Finally, we have the supernode, and the supernode sits on the client side. However, is the one that is receiving the instructions from the superlink, but the actual execution communication happens on the client app. So the client app is the one that contains all the instructions that are specific to the Flower job we are actively going to run. I didn't go into the port side, but basically we just want to show that by default, these ports that we have available are the default ones from 91 to 93 are used by the Superlink component, and 94 is used by Supernode component. Of course, they can easily be changed and configured depending on the requirements that you have for your deployment. Two more components that some other under the hood, things are happening on the Flower deployment runtime is the two different modes that we have. One of them is called sub-process mode, and the other one is called process mode. We're going to dive into both of them. And what I'm describing here is the sub-process mode. So assuming we have a Flower Federation that consists from one server and two clients, the containers that we need in order to execute our Flower deployment or Flower infrastructure in this sub-process mode contains one superlink and two supernodes. As you can see on the right-hand side, we have the server. The server is a single Docker container. We build one single Docker image and we spawn one single Docker container that contains both the superlink and the server. On the client side, similarly, we have one single dedicated image. We create one image and then we spawn another container, and we have supernode and client app both within the same container. And this happens for every other client in our federation. Again, this is the sub-process mode. So basically, the server app and superlink are co-located or appear together on the same container. And again, the supernode and the client app appear together on the same container. The next one, which is the process mode, and this is the one we're going to use throughout our deployment on the Google Cloud platform, consists of a little bit more containers. And the reason is that we are isolating the execution of the different components and subcomponents in our federation. So again, on the same example, we have one server and two clients. The containers we need here is is a little bit more. One is the Superlink, and one is for server apps. So we have dedicated containers and specific images and dedicated containers for each one process. And then we have two supernodes and two client apps. So one image for supernode and one image for the client app. So, and this is going to run on dedicated containers. The reason we're doing this isolation is because it can give us a little bit of flexibility on how to isolate resource management and give us a little bit also more control on how we provision resources during the execution of our Flower job. And again, moving forward, we're going to focus more on the process mode, even when we do the deployment on the Google Cloud Platform. So now, so far, we have seen what are the core components on the Flower side. Now we're going to dive a little bit more on the Google Cloud Platform and how everything is put together in order to make sure we can have an active deployment of Flower on GCP. Just to give you a little bit of background, what is some core concepts that we need to be a little bit familiar with is, first of all, the Google Artifact Registry. So the Google Artifact Registry is, we can think of it as a space or a blob storage where we save images that we want to use during our deployment. Kubernetes is the orchestration tool that's going to basically pull from the artifact registry the images we want, and then deploy the containers of dedicated pods in our infrastructure, in our resources. One more item that we need to actually emphasize here is that throughout this deployment that we're going to show shortly, the entire deployment is happening through the Google Kubernetes Engine autopilot mode. So the provisioning of the resources and the automatic deployment of the pods is happening using the autopilot. There is also another mode that's called standard mode, but we're not going to cover it in this guide. I also want to give a little bit of background on necessary Docker and Kubernetes Engine CLIs that we're going to show shortly and use throughout this demo. So on the Docker side, there are three core commands that we need to be familiar with. One is the Docker build, where we build the dedicated images we need for the Flower application. There's a Docker tag, basically where we tag our image with the Google registry that we want to upload our local Docker image, and the Docker push, of course, where we upload our local image to the container, the Google registry. There's also, of course, the gcloud CLI, where basically through which we configure our local Google Cloud SDK. There are a couple of, I'm not going to dive in each one of them, but the core idea is how we interact with the Google Cloud infrastructure. So how we perform authentication, how we receive the credentials in order to be able to submit jobs to GCP and related works. Finally, there's also the most critical one is the kube control, which allow us to interact with an active Kubernetes cluster. And the core idea here is that we configure the current context, basically the current Kubernetes cluster we want to run our job, and then we apply the YAML files, or where the YAML files are actually Kubernetes or deployment files we're going to use and are specifically recognized by the Kubernetes engine in order to do the deployment of the pods. And lastly, is the get service superlink service. This is specific to Flower, and the reason is by naming specific, the superlink service, basically when we deploy the service, the superlink service or the superlink component, there is an IP, an external IP that we want to interact with. And in order to get this IP, we need to find out how what is the IP assigned to the pod of the superlink component, and we can get that through the get service. We will show that shortly through the demo. Right now, just to give a final overview, what we're going to achieve, and throughout this exercise and the demo side, we have already created a project that's called Flower GCP. This one is basically contains the control plane, so the Kubernetes server that orchestrates the entire execution, and then we're gonna deploy basically 3 nodes, one dedicated for the server, which consists of the Superlink and server app, and 2 more nodes that consist of super nodes and client app for each one respectively. What we show on the connected lines are the ports that we show at the very beginning of our presentation, where how the user interacts with existing Kubernetes cluster, and how the nodes, the clients or the super nodes interact with the Superlink through which port and which service. Let me share Wait 1 second. I'm gonna switch. Hopefully, let me see how can I do this quickly. Um, what is this? Sorry, I'm trying to find. Can you see my screen here with the Google Cloud Platform?
We see, yes, is welcome,
Okay,
Dimitri, blah, blah.
perfect. All right. So what I want to show here is what we have created. We have created the Flower GCP project, right? And we have on the left-hand side, we have a couple of controls. What I'm going to go into is the compute engine, and then I'm going, sorry, in the Kubernetes engine, and then I'm going to the cluster, right? So there is a cluster, and in the cluster, we have created already the Flower NumPy example. So what we're going to run through is we're going to showcase how you can deploy a simple NumPy example on GCP. So if we press on this one, it's going to give us an overview of what is the region, what are the default zones, what are another configurations for the specific cluster. One item that we have done already is actually creating the pods. And the reason we create the pods is because it takes some time to initialize them. So we have pre-created them. And as you can see here, we have basically 6 pods already deployed. One is client app, the one is the Superlink server app, the Supernode, and client. And since we have all these pods deployed, I'm going to show in real time how we can achieve in general interaction with the Google Cloud Platform. On the left-hand side, if you can see my, I hope you can see my Visual Studio here. Is it?
We see the web page with this listing of systems.
Yes, I want to, let me change screen sharing. Okay, let me share this one. Okay, hopefully you can see this one now. All right.
Yeah,
Yes.
we see it.
Perfect. Okay, so what I want to go over is, so we have created with Flower new a very simple Flower NumPy example. As you recall, there is a client app, there is a server app, there is a task that I want to run, and then there are dedicated client app Docker file and the dedicated server app. So what we need to do at the very from at the beginning is we need to generate the specific Docker images that we want to deploy the containers with. So so the idea is that we compile those, and then through the Docker Docker build, we compile them, we tag them with the registry, and then we push them to the Google Cloud. And as you can see here, just to give also another overview of the different helpful commands we can use, we have created the Flower NumPy example, and basically here's the build and the tag and the push. Now, one more thing that we need to cover, which is sometimes not clear, is again how we configure the Google Cloud SDK. So the idea, as we saw previously during the talk, is how we get the credentials, how we make sure that our local Google SDK interacts with the existing Google Cloud Platform. So what we're doing here is we're getting the credentials from the project we saw earlier, or the cluster, excuse me, we saw earlier in the Google Cloud UI, and then we get the current context in order to make sure that we are actually pointing to the correct cluster. Then we enable the artifact registry. This is actually where we're going to push our local client app server images, and then we create the Google registry where this push will happen. After we authenticate our local Docker, we build our client and server app images, we tag them with the respective registry, and in the end, we are actually pushing those images to the Google registry. Last but not least, what I showed before is basically we show 6 pods already deployed, and this can be done through the kubectl apply, where we pass the YAML files that we want to deploy on the Kubernetes cluster. And what we want to run right now is we're gonna run this command, assuming everything already is deployed. So by running, maybe I can actually make it a little bit bigger. So if we run this, so we already know that the current context is pointing to our Flower NumPy cluster. So what we want to get from the Superlink service is this external IP. This external IP allows us to interact with the remote Kubernetes cluster, and we take that and we go to our project TOML file. This is pre-filled already, but we take this and basically we put the external IP in this address. By doing so, we allow our local, Flower CLI to interact with the GCP deployment we have created, and what we're gonna run right now is basically run the GCP deployment. As you can see on the left-hand side, we have created this one. Yeah. And as you can see on the left-hand side, basically this address, we're running in the insecure mode because we can still run everything on TLS side, but right now for simplicity, we run on the insecure side using non-encrypted communication. So what I saw on the right-hand side on the terminal, you'll see that we have submitted the job on the Google Cloud, and then we have 2 clients, of course, and then we're gonna run for 3 rounds, and the entire execution flow shows basically the results we get from every other round. So this can be extended to any other Flower application you have, any other custom Flower application that you want to run. So it's not specific to this particular app. So that I'll definitely suggest going and trying out on the application you want to test out. Let me get back to the previous one. And then let me. Is the slides visible? Are the slides visible?
Yes.
Okay, perfect. Thank you. So one more item that I want to emphasize here is the Flower close deployment. So far, what we show is basically how we have been able to deploy a cluster that is on a specific region and belongs to a specific project. Now, what we can easily extend to is run Flower across different regions and different projects, and of course, across different clouds. So as you can see on the right-hand side, you see a project that is deployed in Japan, another one in Middle East, another one in North America, another project that is running on AWS. So this everything can be done through PRVPC infrastructure and networking, and basically be able to run a Flower job across many different complicated scenarios or infrastructure. Lastly, but not least, I want to emphasize that we're happy that we have actually recently also launched our pilot program, the batch 3, and we are open to any suggestions that, for instance, if you want to run a production workload using GCP, feel free to reach out, and then we're happy to get you throughout the entire pipeline and how to manage to do that. And the applications are open, and we are more than happy to help you run your Flower application, or even test out test a new Flower application into a more production setting. To summarize, throughout this presentation, what we have seen is the Flower deployment runtime, so different runtimes that Flower can currently support, from simulation to deployment to cloud, and to many other third parties. Some very core CLIs, like how you create a Flower in your template, how you run the template, and many other CLI tools that you need specific to the GCP cluster, which is how you build your local Docker images, how you push them, you tag them and push them, how you configure your Google SDK and the kube control. And we focus again on the process mode. So basically every other container, we create a dedicated image for every other component, the subcomponent, and every other image is running on a dedicated container. We have also put together a very comprehensive guide on how you can run Flower GCP, which is in our framework documentation. And it would be great to test it out today and try out your different applications you want to test. Yeah, and then room for questions.
Excellent. Thank you so much. That was great. We're running a bit low on time, but if anyone's got a quick question, feel free to just dive in here, and we can answer them for you. Yeah, if there's any, but if there's no questions, we probably can just sort of start to wrap this up. Um, I've got to say that we've had a lot of people wanting to use Google Cloud, both researchers who are working with partners who have their data already in Google Cloud, or the organizations already signed off on using Google Cloud. So it makes sense when they want to build federations of these environments. It makes sense to sort of run Flower with Google Cloud in those settings. We've also worked really hard with the Google Cloud security team to have a sort of a combination of methods that you can't find in other settings. And then, of course, you mentioned a lot of the production scenarios that people have asked for. Yeah, but that was perfect. I think I don't see any questions firing in, but people can follow up with you on our Slack through the pilot program. We've helped various kinds of organizations, big companies, startups, research labs, a variety of them. So yeah, so thank you very much. That was awesome, awesome talk and demo.